Good morning, everyone. Today we are going to check our proofs from yesterday. And in doing so, what I'm going to do is I'm going to walk through each of the 4 proofs assigned. If you need to skip ahead just to see, hey, did I get that proof right? And kind of come back and watch the video only if necessary, you may do so. I'll make sure that the problem is on top and the proof is going on below. But let's not waste time. Let's get started with number 1. Now remember that in these sorts of proofs, our goal is to figure out if triangles are congruent. And you need to make sure to get as much information as possible out of both the givens and out of the picture. And my first step in proving anything is proving it to myself. I need to know that I actually understand how it works before I start trying to fill in everything here. So I'm going to go through my givens. I know that BC is congruent to CD. So that means that this segment BC is congruent to this segment CD, and that was given. The next thing that I know is that AC bisects BCD, the angle. So this AC is going to come through BCD. And if I check my theorem sheet, I notice that there's one for angle bisector. And it tells me that angle 1 is then going to be congruent to angle 2 due to the definition of bisector. In particular, angle bisector. So now I'm going to just confirm. I used my first given, I've used my second given, so now I need to find information outside of my givens. So let's look at what else I might have. And remember, always check for vertical angles, check for shared things like shared angles or sides. And if I look at this, notice how AC is being used by both the triangles. Well, that means that it must be congruent to itself. That, in turn, tells me I've got a side, an angle, and a side. Therefore, I can do side, angle, side as my support that these triangles are congruent. So I can fill out my proof. And for this proof, I'm going to start with my givens. I know for my first side that BC is congruent to CD, and that was directly given in my statements. Now I want to move on to my angle. I've done my first side, I've taken care of that, and I know that I use definition of bisector, but don't forget that you can only use bisector if you've already told somebody that it is an angle bisector. And so that's going to be this given statement here. AC bisects angle BCD. And that was given to me. Now notice that everything listed in your given should take place on your table. If it has not been moved over to your table, you've probably missed a step. And these are going to be those easy points right there because you know that there's something that needs to go on your table, so it's one more thing that you have correct on your table. Well, now that I know that AC bisects BCD, the angle, I want to use that to state that the angles are congruent. So angle 1 is congruent to angle 2, and that is the definition of angle bisector. Please make sure that you do write angle here because just bisector is talking about a segment, and well, we're not talking about segments here, we're talking about angles. So that brings us to our next one. In our final side, what I want to say is that AC is congruent to itself. And that is according to the reflexive property of congruence. So now that I know side angle side is true, I can state that the whole triangles are congruent according to the side angle side triangle congruence theorem. And so I add that to my table. And I double check that I have put in every single piece of information. So my givens are there, I have a side, an angle, and a side, and I have my final statement exactly the same as what they wanted in their final statement, the proof. That's problem number 1. Looking at problem number 2, I'm going to follow that same process. So the first, prove it to myself, going through the givens one by one. So I know that C is the midpoint of BD. So since C comes exactly in the middle of BD, according to the definition of midpoint, I know that I'm allowed to add these 2 markings. And I double check my sheet that it actually says I can say these 2 are congruent. And it does. So I'm going to write definition of midpoint there. so I know why I made that conclusion. And I've used my first given to make a conclusion. The next piece of information I'm given is that AB is congruent to ED. So AB and ED are congruent. And that was just given to me. Next, I know that AC is congruent to EC. So since AC is congruent to EC, I can add that marking. Well, that's really nice because right here I have three sides congruent to each other, and I haven't even had to go outside of my givens. So that means, according to the SSS triangle congruence theorem, I know these triangles are congruent, and I can go through my proof. So I'm going to do so, making sure that everything in my givens up here ends up on my table. So I'll start with C is the midpoint of BD, and that is given. And I'm going to use that given to prove my first sides are congruent. So I know that BC is congruent to, notice how here B looks the same as D. That means that those are corresponding points. So when I'm writing my next segment, I want to replace B with its corresponding point, which is D. And C is going to be replaced by its corresponding point. But notice how C looks the same in both triangles. That means that C actually is its own corresponding point. So I get BC is congruent to DC. And that is not given to me, right? I had to figure that out using the definition of midpoint. And I'm just going to double check. I just used a definition. Have I mentioned that it's a midpoint? Yes, I have. So I know that I'm good to go. And I've proven my first side. My second side is AB is congruent to ED. And that was a direct statement that was given to me. For my third side, I know that AC is congruent to EC, and that was a statement directly given to me, which means overall the triangles are congruent. So triangle A, B, C is congruent to, well, A corresponds with E, so I'm going to replace the A with the E. B corresponds with D, so I'm going to replace the B with the D, and C stays the same. So I have triangle EDC, and that was according to the triangle congruence theorem SSS. So SSS triangle congruence theorem. One thing to watch out for with this, these are not vertical angles. Vertical angles will take only two lines to draw. You won't have to change direction or anything, just two straight lines. Notice how these do not have two straight lines, but actually have three. I have the BCD right along the bottom here. I have this going up to E and this going up to A. That's three lines here. In our next proof, again, I'm going to start by going through my givens. So I want to prove not this statement, but remember, for right now, I'm just proving that the triangles are congruent, and we will deal with this later. So I'm going to start with my given AB is congruent to AC. AB is congruent to AC. Next, I'm going to look at this statement. AD bisects CB. So this line AD coming down is going to bisect CBC. So when we look at our definitions there, the definition of bisector for a segment tells me that it's going to split it into two congruent segments. So that means that BD has to be congruent to CD since it's been split by this bisector. But I've now used both of my givens. So I'm going to have to check the picture for other givens or come back to these and see if I can figure out some more. Well, a lot of people want to write that this is 90 degrees, and while that might end up being true later on, I don't currently have enough information. The only way I'd know that this angle was 90 is if this was a perpendicular bisector, and I'm only told that it is a bisector, so it could technically come at any angle, though maybe you'll be able to prove later on that it is 90. Since I don't have that, I'm going to look for things like vertical angles. Well, I don't have any two intersecting lines like vertical angles tend to be, like nothing that looks like this. So I can't have vertical angles in here. but I do have a shared side, and that is the reflexive property helping me out here, because that tells me that AD is congruent to itself, which means I currently have side, 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 and I can prove that the triangles are congruent. So I'm going to go through this in the order that it was given to me, starting with AB is congruent to AC, and that is given, and I've already proven one of my sides. Second, I'm going to go with AD bisects BC, and now this is a given, and I used it in order to prove that those two sides are congruent, but I do have to start with that given statement in my proof table, so that people, even without having this stuff laid out for them, have that full information available. So I know that AD bisects BC, therefore I'm going to be able to say that BD is congruent to CD. And that is according to this word bisects, so I can use the definition of bisector. Please make sure you are not using the definition of angle bisector, because it is not told to us that that is an angle bisector. It's only told to us that it is a bisector, which refers to segments. Well, now I finished my second segment, and I only have one to go. So this is the AD, and I know that AD is congruent to itself, and that is according to the reflexive property of congruence. And since I have all sides, I can now say that the triangles are congruent according to the SSS triangle congruence theorem. And that gives me my final triangle ABD is congruent to triangle ACD. And again, you could have named it in a different order than me, provided A still corresponds with A, B still corresponds with C, and D still corresponds with D. So B and C essentially get swapped out in your statement. And that is proof number 3. For our fourth and final proof, we're told that PO is congruent to MO. So I'm going to start by drawing that in. PO and MO are congruent. But unfortunately, I've now used all of my givens, except notice this. These markings here tell me that the lines are parallel. And whenever we see parallel and you're looking at your sheet, there should be a big flag that goes off, and that is that when you have parallel lines, you can probably use the alternate interior or alternate exterior angles theorem. And what that's essentially going to tell us is, if you look at these two parallel lines as if they were just normal parallel lines cut through by a transversal, alternate interior angles like this guy, angle M, and this guy, angle P, will have to be congruent to each other according to the alternate interior angles theorem. And notice that this is also a second transversal, which means that this angle here and this angle here, since they are alternating interior angles, will have to be congruent to each other as well. Which means I currently have an angle, and a side that's not between them, which means this is angle, angle, side, one of our triangle congruency theorems. So let's record this. I'm going to start with, actually this time, my side, because I'd like to get my given out of the way. And remember, it's okay to change the order of your angles and sides, provided that you use all three of them prior to making your triangle congruency statement. So here, PO is congruent to MO, given. Our next statement is going to be that our lines are parallel. And you can do this as a statement PN is parallel to LM, or you can write it all the way out. And this is given to us by the markings. And you have to have this line if you're going to use the alternate angles theorem, alternate interior angles theorem. So make sure you have that. Once you have that, the rest falls into place, so it looks like this. Please double check that your corresponding parts are congruent. You may have gotten a different answer by using vertical angles to use ASA. Here's the proof for that. Don't forget that first step.